Okay, so in 34, we're given these 3 points. We're asked to find the equation of the quadratic that would give us all the points, not just 3 of them, but infinite number of points. So given these points, and knowing that a quadratic is written as ax squared plus bx plus c, we can take each point and plug it into this equation, and then we'll be able to solve for a, b, and c. How come we needed 3 points, you know?
Because that's
So it's not just a line. Yep, 2 points to find a line. What else? When I start doing this, let me start writing, and then I'll ask the question again and see if you can come up with it. So what I'm doing is I'm taking the x and the y and I'm putting them in here. So I'm going to rewrite this with the y as -1 in my first equation. It's not really equals. It's like this is me substituting in. And then I don't know a, so I'm going to leave it a. But x squared is going to be +1, so I'm good there. And then plus bx, that's going to be b times -1. There we go, -1b. And then c is just itself, because it doesn't have any x's there. So I put y here, and x here and here. And I'm going to do that 3 times. So y is 1. Nope, y is 11. Don't let me do that. Y is 11. X is 1 squared is 1. And then b, and then c. And then 7 is y. 3 is x. 3 squared is 9. 3b plus c. So I put x here and here. Does that make sense, everybody? Okay, now that I've got it set up, like as far as I can go, how many variables do I have? 3 variables. How many equations do I have? You have to have 3 variables for 3 equations, 3 equations for 3 variables to solve, or you don't have enough information for things to cancel out. So when we were in the last chapter doing systems of equations, that's where we needed the 3 variables. If we had 4 variables, we'd have to have 1 more equation. So now we have enough to do this. We want to eliminate. This is not the problem where we have a very simple one, and I actually put a second equation, like a whole one worked out, in the homework just for reference. You don't have to do, but if you got stuck, that was meant for you to do for reference. So if we want to cancel things out, what 2 equations would we like to use first? Yeah. First one from the second one. Okay. So we're going to go, and normally, like before, we called these X, Y, and Z, and I labeled them A, B, and C, and now I can't do that because it's really awkward. But Maddie said, and Amelia said the first and second. I'm going to use, Maddie said subtract first one and the second one. Which one am I changing the sign? Okay, so I'm going to write the second one down and leave it the way it is. And I'm going to write the first one down underneath it and change all the signs. So I'm going to have +1, and then -a, +b, and -c. And the goal might have been, if it were me, the goal might have been to think, well, c's are going to be easy for me to cancel. I'm going to go for that. But look what happens with these 2 equations when we add them together. What happens? Yeah, it takes away 2 things. So all at once, we've got b. 2b equals 12, so b equals 6. Like we've already got 1 variable. And we could plug that into all of these and go from there. Or we could keep aiming for canceling out c. That could still be a choice because that's pretty easy between these last 2. Stephen, go. What you got?
How do we go from -1 equals a plus negative?
Okay, so we wrote this one exactly the same, and we wrote this one, and we wrote it times -1. Yeah. So in my earlier lessons, I would have labeled these A, B, and C, but that's awkward now. I was going to label them star and stuff, but then I figured I would totally throw y'all off, so I didn't label them star. Anyway, so since we've used the first 2 equations, we need to use the last equation somehow in my next one. What can we do? What would y'all like to do?
You plug in.
You could plug in. You could go ahead and plug in B. Pick two equations for me to use. You want me to plug in B in all of them?
The second and the third one.
Second and the third one. Okay, so Nathan says second and third one. I'm going to go over here and write them. If I write the second one, it'll be 11 equals A, and then B is 6. You want me to substitute in? Okay. Plus 6 plus C. And then this last one's going to be 7 equals 9A plus 3 times 6 is 18 plus C. So now we have two variables and we have two equations written neatly together. What can we do between the two so that something will cancel?
You multiply by negative.
Which one? First one or second one? Second one. Okay. So I can make them all negative. And I could rewrite them again with the 18, but I'm not going to. Just for now, I'm going to change all the signs. And that gives me 4 equals negative 8A minus 12. Is that right? Okay. So now we can solve for A. We only have A. The C's canceled. And the B's were replaced. So now we're set up to solve for A. If we add 12 to both sides, we'll have 16 equals negative 8A, so A equals negative 2. And if we have two of the three, we can pick any equation. The first one might be easy. Negative 1 equals, and we can plug in A, so negative 2, and then negative B plus C, and now we're ready to solve for C. So we have negative 1 equals negative 8 plus C, add 8, so 8. And 7 equals C. And when we have A, B, and C, we actually put them in this quadratic formula that we have up here. So we have y equals A, negative 2x squared, plus 6x, C is 7, plus 7. And so this is our quadratic. That this point works, and this point works, and this point works. We came up with them from the three equations. So it was good review of systems of equations. We have three variables and three equations. It was nice that anyway we worked this one with A and B, we only had one variable left. That was convenient. So even though it had the potential to be a really long problem, it was only a medium long problem. Yeah. Okay, so what other questions from the homework? So how do we feel about the three forms? Can you pick them out? Like what stuff you're given? Sorta, medium, okay. Okay, the one that doesn't come up the most, at least in my estimation, is the vertex form one. So let's do a problem like this in intercept form and see if we can come up with the same stuff. So let's say that we have this. So this is a new example for today, and then we're going to start our review for our test. So let's say that we're given x-intercepts -2, 0, and 4, 0. With a shrink factor of 1/2, and it's concave down. Concave down. So I'm giving you 2 points. I'm giving you more information about its shape. And I would like for you to take either vertex form, intercept form, or standard form and find the equation of a parabola. And you can leave it in one of those forms. You don't have to rewrite it in another. And there's a short way to do it. So the instructions are find an equation for this quadratic. And I'll give you a few minutes to think about it. What they've got. Stephen, what you got?
I don't know if I did the shrink factor right.
Okay.
I got y equals x plus 2 squared over negative 2 plus 4.
All right.
Negative 2 on the bottom.
Negative 2. So you
And
have
squared.
this. You have a lot of good stuff here. I want to talk about what form this is, though, and what we've been given.
Oh, did I put the intercepts into the vertex form?
Yes.
Oh,
And but this is today. This is perfect, right? We want to find these happy mistakes today so we figure them out for later. So the idea here is that this particular equation has all the pieces that we need. It has the numbers that we need, but in the wrong places. Because if we multiply this out, it's not going to factor the same. These being intercepts means that it needs to look like vertex form, which we'll write out in a second. So he's got the negative, which means it's going down, and the 1/2. And for vertex form, I'm going to just write them in the front, just because sometimes that seems easier. But in this case, this tells you all of the shifts from 0, 0. So this has a different vertex. It has, and I don't know, this might have a vertex. Did that work out? We might have to multiply it out and see. I don't know that that's necessarily wrong. But let's see. We need to change these two guys into opposite math. So you're right about the +2. And then how do we write the 4 in this? -4, opposite math. Because if we were to take these and solve them the way we're used to doing it, we would write x plus 2 equals 0, and that's how we get -2. And we would write x minus 4 equals 0, and that's how we get +4. So we're thinking about working this backwards. So this now works. I'm not sure if we multiply that out that we're going to get the same -3 or not.
Could you go ahead and simplify it out and just say y equals x plus 1, x minus 2? Would that be correct?
Say one more time. Y equals
x plus 1, x minus times x minus 2.
So that's another good question. Okay,
Right.
so this is incorrect. I'm going to erase this, and we might put this one in standard form, but it won't be that. So that part wasn't exactly right. Your question now is, can we multiply this out? I think that's your question. -1/2 x plus 2 x minus 4. So when I like to multiply, first I want to do these together and do the 1/2 later because it's a fraction. But when you were saying out loud to me, miss the part where x also gets a half.
Oh.
So when you do the property where 3 things are multiplied, you can choose the order, right? Commutative property, you can multiply it however you want. So I would do the 1/2 last and FOIL these two together. So this answer was done. Like, that's all I need. In case that's a question for you, you don't have to rewrite it in another form. It is the form of a parabola. It can be done. But if someone said, hey, can you put it in standard form, you would have to multiply it out to get the x squared, the -4x, +2x minus 8. And then the 1/2 would go everywhere. So this actually becomes -2x. So Stephen, I think we need to make sure we have -1/2 x squared. That part was maybe missed. And then 1/2 times -2, that's going to be positive x and +4. So that would be the standard form. It still goes down. It still has a shrink factor of 1/2. How do we get the vertex from either one of these forms? So this is standard form. How do we get the vertex? totally leaving that open to you. You're going to need to be able to find the vertex from any of the forms. And you might prefer one form or the other. Stephen, what do you think?
You find the opposite of the terms being added or subtracted from x. So it would be. Oh wait, that's the vertex.
Well, we're looking for the vertex.
Um,
Luis, did you have an alternative?
Is it negative b over 2a?
So for this form, you can use negative b over 2a. If you happen to have this form or you want to use this form, you would multiply it out. You could use negative b over 2a. Stephen, back to this one. Let's graph it just quickly, like the intercepts, right? We were given negative 2, 0, and 4, 0. Where's the vertex going to be?
It's going to be like the second quadrant.
It's going to be in the second quadrant?
I don't know my quadrant numbers.
Give me an x value. Where is the x value going to be? If these are the same, like these are the here.
Isn't it going to be like x? Isn't it going to be like a half?
It's going to be, half is important there. How do I get halfway between these two? Like, how far apart are they?
They're 6.
They're 6 apart. Where's halfway in the middle of 6?
3.
3. So we need to go 1, 2, 3, and 1, 2, 3. We end up at the same place. There's the half that you're looking for. So this is the folding point, or the axis of symmetry. We're looking for x equals 1. Luis said negative b over 2a. Let's see if we also get 1. And we're going to have a fraction of fractions. It's going to be fine. Tell me negative b. Everybody? Negative b. Negative 1, yes? Over 2 times negative 1/2. What's that going to be? So negative 1 over negative 1 is 1. So that works. We found that. And we would take that 1 and plug it back in either equation, either right here twice or over here twice, to find out the actual value. So when you said second quadrant, I'm thinking this quadrant, but the vertex is really going to be in the first quadrant. Does that make sense? First, second, third, fourth. So the vertex is going to be up here in the first quadrant. Because this goes down, it's going to go down. And if we plug in 1, let's finish this out. We'll have y equals negative 1/2, 1 plus 2, 1 minus 4. That's 3. So negative 1/2 times 3 times negative 3. So 9 halves. 9 halves is 4.5. 1, 2, 3, 4.5. Right here. And I have the parabola. Right? So what I'm saying to you is at this point in the chapter, we've learned how to factor. We've learned how to, so we could find this form if it was squared. We've learned how to complete the square, which we haven't done in today's stuff. But these forms need to be familiar enough where you go, hey, if they give me x-intercepts, I just plop them in the equation with opposite math. Like all of those things have to come together. And then the negative b over 2a, everybody should be able to come up with that on their own because that's so straightforward. You don't have to actually have to complete the square on this, which would not be fun, right? Who wants to complete the square? You'd have to divide by a half and then take half of it. Too many things. So negative b over 2a is very straightforward. Okay, so that was my review of 4.10, 4.10. How about other questions from that section? Yes. So what I would like for you to do now is I have a book. If you have your book or you can go get your book, the chapter review is already posted. I would like for you to work on, I don't remember what it's chapter test or chapter review. I'll look and see what that is. Work on it in class. You can ask me questions. Tomorrow we'll have some time actually to work on it some more and answer questions. I'm not going to just lecture you for the whole double block tomorrow. I'm going to leave that open for questions, and I'm going to change the due date for it to be like at the end of class, so you have time to work on it some tomorrow in class as well, and then your test is on Friday. Okay, so I'll post that for you here and change the due date.